First problem, let f of x equal to x for -2 to -1, x square plus 2x minus 1 to 0, 2x minus x square for 0 to 1, and 2 minus x for 1 to 2. So draw the graph of f of x and discuss continuity and differentiability of f of x in closed interval -2 to 2. Also find composite function f of x and discuss continuity in closed interval -2 to 2. So the graph of f of x, so between -2 to -1, it is a straight line, and between -1 to 0, it's a parabola, and between 0 to 1 is also a parabola, and again between 1 to 2, it is a straight line. Now, so from this graph, you can say directly that it is continuous in closed interval -2 to 2, but it is not differentiable at -1 and +1 because they are corner points, and we need to verify at 0 only. But if you calculate left hand derivative and right hand derivative at 0, it will be the same. So it is not differentiable only at x equal to 1 and -1. Now, to calculate the composite function f of x, so replace wherever x is there with f of x in the entire f of x piecewise function. So f of x will become f of x -2 less than or equal f of x less than or equal -1, f of x whole square plus 2 f of x -1 less than f of x less than or equal 0, 2 f of x minus f of x whole square, 0 less than f of x less than or equal to 1, and 2 minus f of x for 1 less than f of x less than or equal to 2. Now, so here f of x lie between -2 to -1. So for what values of x, you have to identify f of x lie between -2 to -1. So from the graph, so f of x lie between -2 to -1 for the values of x -2 to -1 only. That means you replace f of x with again x, so -2 to -1. Next, f of x lie between -1 to 0 for what values of x from the graph. So f of x lie between -1 to 0. So this is the portion of the curve. That means the x values is also -1 to 0. Now replace the second part f of x with x, that is -1 to 0. Next, 0 to 1 f of x. So f of x lie between 0 to 1. So f of x lie between 0 to 1. So x will lie between 0 to 2. So replace this 0 less than f of x less than or equal to 1 with 0 less than or equal to x less than or equal to 2. Next, fourth part, 1 less than f of x less than or equal to 2. But f of x cannot have any value for 1 to 2. So that means this fourth part you can eliminate directly. Now, when x lie between -2 to -1, observe the graph. What is f of x corresponds to? So for -2 to -1, f of x corresponds to x. So replace f of x with x. Next, second part, for -1 to 0. So for -1 to 0, so f of x is a quadratic, which is x square plus 2x. Then we replace f of x with x square plus 2x. Next, when x lie between 0 to 2, means you are having two parts. So you have to split at 0 to 1 and 1 to 2. For 0 to 1, we have to replace f of x with 2x minus x square. And for 1 to 2, you have to replace f of x with 2 minus x. So from this, again, we can conclude that f of x is continuous in closed interval -2 to 2. Second problem is, let P be any point in the first quadrant on a curve passing through the point 3, 3, and the foot of perpendicular from P to x-axis is a point A and to y-axis is a point B. Tangent at P intersect with x-axis at R and y-axis at Q. Now, if 2 times area of triangle PAR plus area of triangle BPQ equal to 3/2 times area of rectangle OAPB for all positions of P where O is the origin, then find all possible curves. Also find minimum distance of P from origin on each curve. Third problem. solve the differential equation dy by dx equal to y into 1 minus xy into x square plus y square upon x into 1 plus xy into x square plus y square. 4. Solve the equation sin to the power of 8x plus cos to the power of 8y plus 2 minus 4 sin square x cos square y equal to 0. 5th, in triangle ABC, A and B are acute and A not equal to B, and square root of sin 2A cos B plus sin B into root of 2 sin A equal to sin A into root of 2 sin B plus root of sin 2B cos A. Then show that the triangle ABC is right angle triangle. So in this problem, second problem, it is also given slope at any point on the curve is negative. So the possible graph of the curve will be this, and the tangent at P x1 comma y1 intersect the x-axis at R and y-axis at Q, and draw the perpendicular to the x-axis at A and y-axis at B. So equation of the tangent at x1 comma y1, y minus y1 equal to dy by dx into x minus x1. Using this, you can write the coordinates of R and coordinates of Q, and you can calculate the length of AR and length of BQ. Now after calculating, then you can write the area of triangle PAR and area of triangle BPQ and area of rectangle OAPB. Then you will get a differential equation x square dy by dx whole square plus 3xy dy by dx plus 2y square equal to 0. It is factorizable. So the factors are x dy by dx plus y equal 0 or x dy by dx plus 2y equal 0. So if you solve the differential equation and use the point on the curve 3, 3, so we will find the two possible curves xy equal to 9 and x square y equal to 27. And the second part is you have to calculate minimum distance of P from the origin. So distance of P from origin is root of x square plus y square. So that has to be minimum. So use the first curve xy equal to 9 and replace y with 9 by x and replace y with 9 by x and take differentiate and equal to 0 and get the minimum value. So the minimum value will be 3 root 2. In the similar manner for the second curve x square y equal 27. So the minimum distance of the point P from origin is 3 root 3 upon cube root of 2. Then the third problem. So inspection method is always preferable. So cross multiply and bring one side and regroup the terms. You can get as x dy minus y dx upon x square plus y square plus xy into x dy plus y dx. So the first term you can write as derivative of tan inverse of y by x, and second term you can write as xy into d of xy equal to 0. So integrate on both sides, then you will get the solution as 2 tan inverse of y by x plus x square y square equal to constant. Right. Fourth problem. So in this fourth problem, you try to rewrite using some perfect squares. So in the fourth problem, we can write the perfect squares as sin power 4x minus 1 whole square plus cos power 4y minus 1 whole square plus 2 sin power 4x plus 2 cos power 4y minus 4 sin square x cos square y equal to 0. Again, by taking 2 common, this also becomes a perfect square. So sum of positive numbers equal 0. So each must be equal to 0. Then you can get sin square x equal to 1 and cos square y equal to 1. So the solutions are general solution x equal to n plus 1 pi by 2 and y equal to n pi. Now, the fifth problem is you bring left side all the terms and write sin 2a as 2 sin a cos a, sin 2b as 2 sin b cos b, and try to take common factors and simplify. Then you can find that one angle is a right angle. So in the fifth problem, by writing sin 2a as 2 sin a cos a, sin 2b as 2 sin b cos b, and take left side, and then if you regroup the first two terms and next two terms and take common and simplify, then you can get root of sin a minus root of sin b into root of cos a cos b minus root of sin a sin b equal to 0. Because a not equal to b is given, so root of sin a minus root of sin b is not equal to 0. So from this you'll get tan a tan b equal to 1, which implies c equal to pi by 2. Sixth problem. The equation t square plus 2xt plus 4 equal 0 does not possesses distinct real roots. Find the equation of tangent of greatest slope to the curve y equal to x cube minus 2x square plus x. Seventh, If the length of the side of a regular pentagon is A and its diagonal is of length of B, then find the value of A square upon B square plus B square upon A square. Eighth problem. Show that x upon 1 minus x square minus x cube upon 1 minus x power 6 plus x power 5 upon 1 minus x power 10 minus x power 7 upon 1 minus x power 14 plus and so on to infinite terms equal to x upon 1 plus x square plus x cube upon 1 plus x power 6 plus and so on to infinite terms where modulus of x is less than 1. So the quadratic equation does not possess distinct real roots. So discriminant will be less than or equal to 0. So from this you'll get x belongs to closed interval minus 2 to 2. So the curve y equals x cube minus 3x square plus x. So differentiate with respect to x. So the slope is 3x square minus 4x plus 1. Now if you differentiate further and equal to 0, x equal to 2 by 3. So second derivative, that is d square m by dx square equal to 6 greater than 0. Now, so calculate the slope at x equal to 2 by 3 and at the end points of the interval minus 2 and plus 2. So at x equal to minus 2, the slope is maximum. So y value will be minus 18. So equation of the tangent with the greatest slope is 21x minus 5 plus 24 equal to 0. Next, for the seventh problem, because it is a regular pentagon and diagonal length also you know, so you can find out the angles of pentagon, interior angles you can calculate. So use the cosine rule and get the relation between A and B. Then you can get the value of A square by B square plus B square by A square. Next, in the eighth problem, take the left hand side and try to prove the right hand side using the infinite geometric progression series concept. In the seventh problem, so the interior angle is 108 degrees. So when you apply cosine rule, so you will get as b square equal to a square into 2 sine square 54. Sine square 54 is same as cos 36. So b square by a square equal to 3 plus root 5 by 2. So the value of a square by b square plus b square by a square is 3. The eighth problem, x upon 1 minus x square, you can write as a infinite GP with the first term x and common ratio x square. So x plus x cube plus x power 5, x plus x power 7 and so on. Second term minus x cube upon 1 minus x power 6 you can write as minus x cube minus x power 9 minus x power 15 and so on. So here the first term is x cube and common ratio is x power 6. Next, x power 5 upon 1 minus x power 10 you can write as first term x power 5 common ratio x power 10 and so on. Now add all the first terms of each series, add all the second terms of each series and so on. Then you will get the right hand side terms.